Hello and welcome to question 2A for the scholarship exam for Calculus 2022. So we're going to consider the equation x squared minus 4x plus 10 equals to k times of x plus 1 squared, where k is real. For what values of k will the equation have two distinct real roots of the same sign? So for this question, we'll just start off by writing our equation in terms of a polynomial. So we have x squared minus 4x plus 10, that equals to k times of x squared plus 2x plus 1. So x squared minus 4x plus 10, that equals to kx squared plus 2kx plus k. And let's rearrange it so we have to make 0 on one side. So we have 0 equals to k minus 1 x squared plus 2k plus 4x plus k minus 10. Alright, so notice we can now divide everything by k minus 1. So we have 0 equals to x squared plus 2k plus 4 divided by k minus 1 plus k minus 10 divided by k minus 1. And in this case, if we let the roots be a and b, we can say that x minus a times x minus b, that is going to be equal to x squared minus a plus b times of x plus ab. So in this case, notice that if both the roots are positive, then ab is positive. And if both the roots are negative, then ab is negative. Okay, so notice that no matter what the roots are, whether it is both positive or both negative, so ab will be greater than 0 if roots are the same sign. So AB is greater than 0 if the roots are the same sign. So we can actually use this information. So we're saying that k minus 10 over k minus 1 is actually greater than 0. So notice that there's two possible cases. So we can have the numerator greater than 0 and the denominator greater than 0. This happens precisely when both k minus 10 is greater than 0 and k minus 1 is greater than 0. So notice that for the k minus 10 is greater than 0, we know that k is greater than 10. And for the case where k minus 1 is greater than 0, then k is greater than 1. But since k is greater than 10 is a more restrictive boundary, we can just get rid of the k is greater than 1. So we know that k is greater than 10, or we know that both of these are negative. So we know that k minus 10 is less than 0, and k minus 1 is less than 0. So k is less than 10, and k is less than 1. So in this case, we can just take k is less than 1, since that's unbounded within k is less than 10. So k is less than 1 and k is greater than 10. Some people may think that we are finished in this question, but one thing we have to also consider is that we want to have two distinct real roots. What does that mean? That from level 2, we should recover that this means that b squared minus 4ac is greater than 0. So let's check the boundary for b squared minus 4ac is greater than 0. And that shouldn't be too hard. So we have 2k plus 4 squared minus 4 times of a, which is k minus 1, times of k minus 10. And that is equal to 4k squared plus 16k plus 16 minus 4 times of k squared minus 11k plus 10. And we can just simplify a bit further here. So we have 4k squared plus 16k plus 16 minus 4k squared plus 44k minus 40. And that equals to 60k minus 24. Alright, so we just bring it up here a bit. So, okay, so notice that we want b squared minus 4ac to be greater than 0. So b squared minus 4ac greater than 0. So 60k minus 24 is greater than 0. So 60k is greater than 24. So k is greater than 0.4. So we know that k must be greater than 0.4, so that will narrow our solutions down to either. So we can have either one of these. We can have one is k is greater than 10, or for the second case, we can have k is between 0.4 and 0.1. So k is smaller than 1, but greater than 0.4. And those are our two boundaries for k. So if k is greater than 10 or k is between 0.4 and 1, then we will have solutions of the same sign. I hope you enjoyed this video, and the main thing of this question is that I think the main point is just noticing that if we have roots of the same sign, then the two roots multiplied together must be positive no matter what. I think as long as you notice that, then the rest of the question really is quite not too hard. It's basically just some level 2 stuff and some inequalities, which isn't really too hard. But I think the main challenge of this question is definitely noticing the fact that a times b, if both roots are the same sign, then you will indeed get a positive value for a times b. So other than that, that's basically what this question was testing you on, and I hope to see you all in question 2b.